It's difficult for us humans to fully comprehend the enormity of space. We're comfortable in our own cosmic neighborhood, the solar system, and are used to familiar faces like Jupiter, Mars, and of course Earth. But beyond the heliopause lies the cold oblivion of interstellar space. Only 3 confirmed objects have ever crossed this threshold into our domain. These were the famous Oumuamua in 2017, Borisov in 2019, and now 3I/Atlas in 2025, visitors that bring with them both scientific excitement and perhaps even a hint of cosmic fear about what else might be traveling between the stars. Beyond the heliopause, our interstellar visitors. The vast expanse beyond our solar system represents one of the most hostile environments imaginable. A realm where temperatures approach absolute zero, and the nearest stars are separated by trillions of miles of empty void. Yet occasionally, objects from these distant stellar nurseries complete journeys lasting millions of years to visit our cosmic neighborhood. Interstellar space begins beyond the heliopause, approximately 120 astronomical units from the Sun, where our star's solar wind can no longer push back against the interstellar medium. Dr. Alan Stern from the Southwest Research Institute describes this boundary as humanity's cosmic doorstep, beyond which lies the true wilderness of the galaxy. The detection of interstellar visitors requires objects to exhibit hyperbolic orbits, trajectories that prove they're not gravitationally bound to our Sun and must have originated elsewhere. NASA's definition requires orbital eccentricity greater than 1.0 and excess velocity that cannot be explained by gravitational acceleration from solar system bodies. These mathematical signatures distinguish true interstellar objects from long-period comets that merely appear to come from great distances. The rarity of such detections makes each visitor precious, windows into the composition and formation processes of distant planetary systems that we may never reach with conventional spacecraft. The third visitor, 3I/Atlas discovery. January 2, 2025 marked a historic day in astronomy when the Atlas Asteroid Survey detected an unusual object that would soon become our third confirmed interstellar visitor. Dr. Larry Deneau from the University of Hawaii was monitoring the automated detection systems when object A11PL3Z appeared in the survey data, moving at an extraordinary velocity that immediately flagged it as anomalous. Unlike typical asteroids that follow predictable elliptical orbits, this object displayed hyperbolic motion characteristic of visitors from interstellar space. Dr. Robert Warwick, the astronomer who discovered both Oumuamua and helped confirm Borisov, led the initial follow-up observations that confirmed the object's interstellar origin. The Minor Planet Center in Cambridge, Massachusetts coordinated rapid confirmation observations from telescopes worldwide, including the Canada-France-Hawaii Telescope and Gemini Observatory. Within 72 hours, enough orbital data had been collected to definitively prove that A11PL3Z was traveling too fast to be gravitationally bound to our solar system. The object's discovery represents a milestone in astronomical detection capabilities, the first interstellar visitor found by automated survey systems rather than manual observation. 3I/Atlas received its final designation after the International Astronomical Union confirmed its interstellar trajectory and cometary activity, making it officially the third known visitor from beyond our solar system. The Atlas Survey System. The Asteroid Terrestrial Impact Last Alert System, or ATLAS, represents a revolutionary approach to sky surveillance, designed primarily to detect potentially hazardous asteroids, but proving equally capable of finding interstellar visitors. Dr. John Tonry from the University of Hawaii leads the project, which operates 4 telescopes across Hawaii and South Africa, continuously scanning the entire visible sky every 24 hours. Each ATLAS telescope uses a 0.5-meter mirror equipped with advanced CCD cameras, capable of detecting objects as faint as magnitude 19.5. The system processes approximately 100 terabytes of data monthly, using sophisticated algorithms to identify moving objects against the background of stars. ATLAS distinguishes itself through rapid cadence observations, taking multiple images of the same sky regions within hours to detect object motion. The discovery of 3I/Atlas validated the system's ability to detect rare phenomena beyond its primary mission. Dr. Deneau noted that the automated nature of ATLAS allows us to catch objects that human observers might miss due to their subtle motion or unusual characteristics. The system's success has prompted NASA to fund expansion to additional sites, creating a global network capable of providing even earlier warnings for both hazardous asteroids and interstellar visitors that might otherwise escape detection. From A11PL3Z to C2025N1, the naming journey. The designation journey of 3I/Atlas really illustrates the complex process astronomers use to classify and name celestial objects. So, initially it was designated A11PL3Z by the Atlas survey system, but, as its true nature became apparent, the object underwent multiple reclassifications. Dr. Gareth Williams at the Minor Planet Center explained that automated survey systems use temporary alphanumeric codes before official designations are assigned. Once hyperbolic orbital motion was confirmed, the object received the provisional designation C/2025N1, which indicates a comet discovered in the first half of July 2025. The C/prefix denotes a non-periodic comet, while 2025N1 tells us it was the first comet found during the 14th half-month period of that year. As observations revealed clear cometary activity, including coma formation and tail development, the International Astronomical Union assigned the final designation 3I/Atlas. The 3I prefix marks it as the third interstellar object, following 1I/Oumuamua and 2I/Borisov. The Atlas portion honors the survey system that discovered it, following IAU traditions of crediting discoverers. This naming evolution really reflects the careful verification process required to confirm interstellar origin, ensuring that only objects with definitively hyperbolic orbits receive the prestigious EIN designation reserved for visitors from other star systems. A hyperbolic journey at 58 kilometers per second. 3I/Atlas approaches our solar system with a hyperbolic excess velocity of 58 kilometers per second, a speed that definitively proves its interstellar origin and provides clues about its cosmic journey. Dr. Davide Farnochia from NASA's Jet Propulsion Laboratory calculated that this velocity places 3I/Atlas among the fastest interstellar visitors ever detected, suggesting either a recent gravitational encounter with another star or acceleration from its parent system. The object's trajectory indicates it entered our solar system from the direction of the constellation Lynx, possibly originating from the Vega stellar system, which is about 25 light-years away. Orbital mechanics reveal that 3I/Atlas has been traveling through interstellar space for an estimated 1 to 3 million years before encountering our solar system's gravitational influence. The object's perihelion, its closest approach to the Sun, occurred on October 30, 2025, at a distance of 0.65 astronomical units, which is well within Earth's orbital radius. Dr. Alan Harris from the German Aerospace Center noted that this close solar approach provides optimal conditions for studying the object's composition through spectroscopic analysis and thermal emission observations. The hyperbolic nature of the orbit means 3I/Atlas will never return. After its solar encounter, the object will be gravitationally accelerated by our Sun, eventually reaching speeds exceeding 70 kilometers per second as it exits toward the constellation Draco. Brightness, rotation, and the 29-hour cycle. Photometric observations of 3I/Atlas have revealed a complex 29-hour rotation period that provides crucial insights into the object's shape, composition, and structural integrity. Dr. Alan Fitzsimmons from Queen's University Belfast leads the International Photometry Campaign, coordinating observations from telescopes worldwide to track the object's brightness variations over time. The 29-hour cycle shows magnitude variations of approximately 1.5, which indicates either a highly elongated shape similar to Oumuamua, or surface features with dramatically different reflectivity properties. Light curve analysis by Dr. Mikael Granvik from the University of Helsinki suggests the object is likely tumbling rather than rotating around a single axis, which is consistent with an object that has experienced gravitational perturbations or impacts during its interstellar journey. The rotation period is significantly longer than typical solar system comets, which usually rotate every 6 to 12 hours due to outgassing torques. Thermal infrared observations using the Spitzer Space Telescope show that 3I/Atlas maintains surface temperatures consistent with its distance from the Sun, but with unusual temperature distribution patterns that suggest non-uniform surface composition. The object's brightness peaked at approximately magnitude 10 during perihelion, making it visible to experienced amateur astronomers using moderate-sized telescopes, but remaining too faint for naked-eye observation, despite its considerable size. Coma, tail, and cometary activity. Unlike the mysterious Oumuamua, 3I Atlas displays clear cometary activity which has, provided astronomers with valuable data about its composition and structure. Dr. Matthew Knight from the University of Maryland leads studies of the object's coma, the fuzzy atmosphere of gas and dust surrounding the nucleus as solar heating vaporizes surface materials. The coma began developing when 3Y Atlas reached approximately 2.5 astronomical units from the Sun, initially appearing as a faint envelope around the central nucleus. Spectroscopic analysis by Dr. Michael DeSanti from NASA Goddard Space Flight Center detected emissions from water vapor, carbon monoxide, and hydrogen cyanide, typical signatures of comet sublimation, but with unusual abundance ratios. The object developed a visible tail reaching lengths of 200,000 kilometers as it approached perihelion, composed primarily of dust particles ejected by outgassing. High-resolution imaging from the Hubble Space Telescope revealed the tail's structure shows periodic variations corresponding to the object's rotation, indicating active regions on the nucleus surface. Dr. Jacqueline Keene from Boston University noted that the gas production rate of 3Y Atlas is approximately 10 times higher than expected for its estimated size, suggesting either unusual composition or internal structure. The cometary activity confirms 3Y Atlas as a volatile-rich object that formed in the outer regions of another stellar system, where temperatures were low enough for water and other compounds to condense. Oumuamua versus Borisov versus 3I/Atlas. So let's compare these three confirmed interstellar visitors: Oumuamua, Borisov, and 3I/Atlas. They really present a fascinating study in contrasts, revealing just how diverse the objects traveling between stellar systems can be. Oumuamua, which was discovered by Dr. Robert Warwick back in 2017, is still the most enigmatic of the bunch. It showed no cometary activity, even when it got close to the Sun, and it had this unexplained acceleration and extreme elongation that made it, well, truly unique among known solar system objects. On the other hand, 2I Borisov, which was found by amateur astronomer Gennady Borisov in 2019, behaved exactly as astronomers expected an interstellar comet would. It developed a classic tail, showed predictable outgassing, and had a composition pretty similar to solar system comets. Then there's 3I Atlas, which represents something kind of in-between. It displayed clear cometary activity but with some unusual characteristics that set it apart from typical comets. Dr. Stefano Bagnulo from Queen's University Belfast led comparative studies showing that Borisov had carbon monoxide ratios similar to solar system comets, while 3Y Atlas showed significantly different volatile abundances. When it comes to size, estimates put Oumuamua at around 400 meters long, Borisov at roughly 1 kilometer in diameter, and 3Y Atlas at an estimated 5 to 10 kilometers across, making it potentially the largest interstellar visitor we've detected so far. All this suggests that Oumuamua might represent a rare class of objects, while Borisov and 3I Atlas indicate that typical interstellar comets actually share a lot of characteristics with their solar system cousins. A 3 billion 11-year-old traveler. Determining the age of 3I Atlas is, honestly, one of the most challenging aspects of studying interstellar objects. It requires some pretty sophisticated modeling of cosmic weathering processes and orbital dynamics. Dr. Grigory Fedorets from Queen's University Belfast estimated the object's age to be somewhere between 3 and 11 billion years, based on its surface spectroscopic properties, and assumed travel times from nearby stellar systems. That's pretty wild. It means 3I Atlas could be older than Earth itself, having formed during those early epochs of galactic evolution, when star formation rates were way higher than they are today. Now, cosmic ray exposure modeling by Dr. Renu Malhotra from the University of Arizona suggests the surface should show significant radiation damage after billions of years in interstellar space, but interestingly, observations indicate a surprisingly pristine composition. The age estimates assume 3I Atlas originated from stellar systems within 100 light-years of our current galactic position, though honestly the actual birthplace could be much farther away, given the complex orbital motions of stars over galactic timescales. Dr. Fatih Namuni from Côte d'Azur Observatory calculated that objects of this age could have originated from star-forming regions that no longer even exist, having been dispersed by galactic rotation and stellar evolution. The ancient nature of 3I Atlas gives us, well, a unique opportunity to study materials from the early solar system formation epoch, potentially preserving chemical signatures from primordial stellar nebulae that formed billions of years ago. October 30th, perihelion and beyond. October 30th, 2025 marked the closest approach of 3I Atlas to our Sun, giving astronomers around the world optimal conditions for detailed study of this ancient interstellar visitor. Perihelion observations coordinated by Dr. Casey Lise from Johns Hopkins Applied Physics Laboratory used, honestly, just about every major ground-based observatory and space telescope to capture as much scientific data as possible. The 0.65 AU closest approach placed 3I Atlas well within Earth's orbit, allowing for unprecedented resolution observations of an interstellar object's nucleus and its active regions. Solar heating during perihelion triggered peak cometary activity with gas production rates reaching 10 to the 28th molecules per second, and a tail stretching over 500,000 kilometers. Dr. Tony Farnham from the University of Maryland reported that high-resolution imaging revealed surface features and active jets similar to solar system comets, but, interestingly, with some unusual spatial distribution patterns. After perihelion, tracking shows that 3I Atlas will stay observable until about mid-2026 before fading beyond the detection limits of our current telescopes. The object's exit trajectory toward the Draco constellation has been calculated with precision, with a final velocity exceeding 75 kilometers per second as it leaves our solar system for good. Looking forward, future observations will focus on long-term monitoring of the tail's evolution and spectroscopic analysis of outgassing products, which will keep revealing secrets about interstellar comet formation and the chemical evolution of distant planetary systems. 3I Atlas has given astronomers an unprecedented opportunity to study pristine material from another star system, bridging billions of years and countless light-years to reach, well, our cosmic doorstep. This ancient traveler carries chemical signatures from stellar environments we may never visit, and its cometary activity proves that familiar processes are at work throughout the galaxy. As 3I Atlas continues its eternal journey beyond our solar system, it leaves behind invaluable data that expands our understanding of planetary formation all across the cosmos. Be sure to subscribe to Stellar Tech for more discoveries about our universe's most distant messengers. What if a rocket intercepted a messenger from another star? Recently, the internet exploded with claims that a Falcon 9 rocket spotted something moving on the surface of 3I Atlas, an interstellar comet older than our own sun. But what's the real story behind this cosmic visitor and the rumors of its interception? The truth is more fascinating than the fiction, revealing the incredible challenges and profound possibilities of chasing these messengers from distant star systems. Let's explore this together. What makes 3I Atlas special? So what's the big deal with this specific comet? Imagine a visitor from a completely different neighborhood, one that holds clues to how other solar systems are built. 3I Atlas isn't just another space rock. It's a pristine sample of an entirely different stellar environment. It was discovered on July 1, 2025, by the Atlas Survey in Chile, a project co-led by astronomer Larry Deneau. That system is designed to spot near-Earth objects, so finding an interstellar guest is a testament to its incredible reach. Astronomers quickly confirmed its hyperbolic trajectory, the telltale sign of an interstellar origin. This object is racing through our solar system at a staggering 58 to 61 kilometers per second. To put that in perspective, you could travel from the Earth to the Moon in a little over 6 hours at that speed. Scientists estimate it could be up to 7 billion years old, predating our Sun. This means it carries a chemical record from an earlier epoch of the Milky Way galaxy. What truly makes it a scientific treasure is its composition. Observations from the Hubble and James Webb Space Telescopes show it's a true comet, complete with a dusty coma and tail carrying water ice, organic molecules, and silicate dust from its home star. The Falcon 9 connection debunked. Here's where the story gets twisted. Did a SpaceX rocket really intercept this interstellar traveler? The claim went viral, fueled by a public fascination with SpaceX's capabilities. But the reality is far more routine. Let's look at the facts. On August 18, 2025, a Falcon 9 rocket did launch from Vandenberg Space Force Base in California. However, its mission, overseen by figures like SpaceX's CEO Elon Musk, was to deploy 24 Starlink satellites into a low-Earth polar orbit. This was a milestone for sure, but entirely unrelated to the comet. There has been no spacecraft from SpaceX or any other agency that has intercepted or interacted with 3Y Atlas. These kinds of rumors spread easily because they blend a known, dynamic entity like SpaceX with a mysterious celestial event. It's a compelling narrative, but it's pure fiction. The scale of an Earth orbit satellite deployment versus a deep space, high-speed intercept mission is colossal. Furthermore, space agencies are incredibly public about their scientific missions. An operation of this magnitude would be nearly impossible to hide from the global network of professional and amateur astronomers who constantly monitor the skies. The truth is, all Falcon 9 launches in that period were for planned payloads into Earth's orbit. The physics of interception. So, why couldn't we just send a Falcon 9 to check it out? The math is sobering. As physicist Andreas Hein of the Initiative for Interstellar Studies has detailed in mission concepts like Project Lyra, chasing an object moving at over 200,000 kilometers per hour is a monumental challenge. By the time 3I Atlas was identified, it was already hurtling outwards at immense speed. To even attempt a direct flyby, a spacecraft would need an epic velocity change. A Falcon 9 is a workhorse for lifting heavy loads, but it's not designed for the extreme velocity needed in deep space. You'd need a specialized and powerful kick stage that fires after the main rocket has done its job, pushing a small probe to incredible speeds. Even then, the launch window is punishingly narrow. Miss it by a few weeks, and the target is simply too far away and moving too fast to ever catch. Even our fastest spacecraft only achieve their speeds by falling towards the sun. To catch 3I Atlas, we would need a mission planned years in advance, likely involving a massive rocket and complex gravity assists, a luxury we simply don't have with these surprise visitors. Alien chemistry possibilities. This is where the science gets really exciting. What if this comet is carrying chemicals we've never seen before? Astrobiologists like Sarah Seeger at MIT spend their careers considering such possibilities. At an estimated 7 billion years old, 3Y Atlas formed in a stellar environment that was likely very different from our own. The water, ice, and organic molecules detected might have structures fundamentally alien to our solar system's chemistry. This opens the door to a profound question related to panspermia, the idea that the chemical seeds of life are spread throughout space by objects like comets. Even more fascinating is the idea of chirality. On Earth, life uses what we call left-handed amino acids. There's no known chemical reason for this preference. Finding the opposite right-handed amino acids on 3I Atlas would be a monumental discovery. It would be powerful evidence for an independent origin of life's building blocks elsewhere in the galaxy. It would be like finding a recipe card written in a language that doesn't exist on our planet, profoundly impacting our search for life beyond Earth, and hinting that the universe is far more creative with its chemistry than we ever imagined. 3 missed opportunities. We're facing a pattern that is becoming painfully clear. In less than a decade, 3 confirmed interstellar visitors have sailed right past us. First, in 2017, came one Oumuamua. This bizarre object baffled astronomers. It showed no visible coma, yet it was accelerating away from the sun, a mystery that led Harvard astronomer Avi Loeb to famously propose it could be an artifact of extraterrestrial technology. By the time we spotted it, it was already leaving. Then, in 2019, 2I Borisov appeared. This one was clearly a comet, giving us our first real look at the chemistry of another solar system. Studies showed it had an unusually high concentration of carbon monoxide, a tantalizing clue that it formed in a very different, very cold environment, but without a sample, it remains a distant observation. Now we have 3I Atlas in 2025, our third confirmed cosmic messenger. It represents another missed chance for a close-up look. 3 unique opportunities, each with its own fascinating mysteries, and 3 misses. It raises the urgent question of how many more cosmic messengers we will simply let fly by while we remain stuck on the sidelines. Future intercept technology. So, are we doomed to just watch from the sidelines forever? Not necessarily. Imagine a spacecraft parked in space, just waiting. That's the core idea behind the European Space Agency's Comet Interceptor mission. Led by principal investigator Geraint Jones, Planned for launch in 2029, this innovative spacecraft won't have a predetermined target. Instead, it will travel to the Sun-Earth L2 Lagrange point, a gravitationally stable spot about 1.5 million kilometers from Earth, and wait, it will lie dormant until astronomers spot a new interstellar object with enough lead time. Once a target is selected, Comet Interceptor will begin the chase. It's 3 spacecraft in one. It will release 2 smaller probes to fly through the comet's coma from different angles, creating a 3D profile of its nucleus and surrounding environment. This isn't the only idea on the table. Some scientists at NASA have proposed concepts for rapid response missions. The goal is to move from passive observation to active pursuit, finally giving us the ability to reach out and touch one of these cosmic travelers. Scientific implications. What if we did manage to grab a piece of another star system? The implications would be, well, just transformative. As cosmochemist Connell Alexander has shown by studying meteorites, analyzing pristine material can totally revolutionize our understanding of solar system formation. Now just imagine doing that for another star. The primary goal here would be to analyze a pristine sample of matter from beyond our solar system. A key technique would be analyzing its isotopic ratios. Isotopes are variants of elements with different numbers of neutrons, and their ratios act like a fingerprint of the stellar nursery where the object formed. This could tell us if it originated in a region rich with the remnants of supernovas, for example. Furthermore, studying its trajectory with extreme precision could reveal subtle secrets. Tiny, unexplained deviations from its path could hint at unknown gravitational effects. And perhaps most compellingly, if we find complex organic molecules, it would really fuel the panspermia hypothesis, suggesting that the building blocks of life are constantly traveling between star systems. We might be looking right at revolutionary chemistry without even recognizing it. Trajectory analysis and mysteries. Let's dig into the path of this cosmic wanderer. The hyperbolic trajectory of 3I Atlas is the smoking gun that proves it's not from around here. Its path is an open curve, meaning it will swing around the sun once and then exit back into interstellar space, never to return. Its high hyperbolic excess velocity, the speed it retains after escaping the sun's gravity, is a key indicator. For 3I Atlas, this speed is around 58 kilometers per second. The object makes its closest approach to the sun on October 30th, 2025, at a distance of about 1.4 astronomical units. One of the biggest mysteries, a puzzle that astronomers like Bill Gray have spent years trying to solve for various objects, is its origin. Astronomers use powerful software to run the comet's trajectory backward in time, checking against star catalogs to see if its path aligns with any known star systems it might have passed millions of years ago. So far, no definitive origin star has been found for any interstellar object. They appear to be true wanderers, ejected from their home systems long ago, and drifting through the void for potentially billions of years. The official facts. So, let's separate fact from fiction and lay out what scientists have officially confirmed. 3I Atlas was first detected on July 1, 2025, by the Atlas survey in Chile. The 3I in its name literally means it's the third confirmed interstellar object. Within a day, its hyperbolic trajectory was confirmed by observatories around the world. As leading interstellar object expert Karen Meach has noted, the global coordination to observe these targets is incredible. It is traveling at a velocity of roughly 58 to 61 kilometers per second relative to the Sun. Hubble Space Telescope images from July 2025 revealed a dusty coma surrounding the nucleus. Spectroscopic analysis by both Hubble and the James Webb Space Telescope confirmed the presence of water ice, organic molecules, carbon dioxide, and silicate dust. NASA has officially stated that the object poses no danger to Earth, always remaining more than 150 million miles away. And to be perfectly clear, despite the viral rumors, no spacecraft, including any Falcon 9, has intercepted or is planned to intercept 3I Atlas. All SpaceX launches around that time were for routine satellite deployments. The bigger picture. In the end, the frenzy over a Falcon 9 intercepting 3I Atlas, while factually wrong, highlights a much deeper truth. Humanity is captivated by the idea of reaching out to these cosmic messengers. We've now seen 3 of these objects in just a few years, suggesting they may be common visitors. With projects like the Vera C. Rubin Observatory coming online, our ability to detect them will only increase. This isn't just a scientific question anymore, it's a strategic one. This connects directly to the Fermi paradox, a question famously championed by SETI astronomer Jill Tarter. If the universe is vast and the building blocks for life are being delivered across the galaxy like cosmic seeds, then where is everybody? Do we invest in developing a permanent, ready-to-launch intercept mission? The technology exists, but it requires political will and financial commitment. The decisions we make now will determine if, next time, we are ready to capture one of these cosmic opportunities, or if we will once again watch it disappear into the void, taking its secrets with it. The universe is constantly sending us messages, written in the language of chemistry and physics, carried on messengers like 3I Atlas. While we weren't ready this time, the future of interstellar interception is closer than you think. What secrets will the next visitor reveal, and will we be there to unlock them? If you want to be here for that next great discovery, make sure you're subscribed to Stellar Tech as we continue to explore the biggest mysteries on the edge of the galaxy. Don't forget to like, subscribe, and hit the bell icon. Thanks for watching. Right now, 15 billion miles from Earth, humanity's most distant messenger is revealing secrets that are, honestly, rewriting our understanding of space. Voyager 1 crossed into interstellar space back in 2012, becoming the first human-made object to leave our solar system's protective bubble. But after a terrifying communication blackout in 2023, the spacecraft came back online with data that absolutely stunned scientists. The space between stars isn't the empty void we imagined, it's actually a dynamic, structured environment filled with cosmic weather, invisible boundaries, and phenomena that challenge everything we thought we knew about our galaxy. The Silent Crisis. April 2024 brought relief after months of cosmic terror. Voyager 1 had gone completely silent, transmitting only garbled signals that made no sense to NASA engineers at the Jet Propulsion Laboratory. After 46 years of faithful service, humanity's most distant explorer was dying. The culprit was a corrupted memory chip, likely damaged by a cosmic ray strike. The very phenomenon Voyager was studying had wounded it. Engineers faced an unprecedented challenge, performing brain surgery on a spacecraft using 1970s technology from 15 billion miles away, where radio signals take over 22 hours for a round trip. The rescue operation required rerouting code into backup memory areas, essentially giving CPR to a robot that predated most modern computers. By May 2024, the patient showed signs of life, with all 4 science instruments gradually coming back online. This wasn't just an engineering triumph, it was humanity's lifeline to the only measurements we have from beyond our solar system. Magnetic mysteries beyond the edge. The first shock came from Voyager's magnetometer readings after crossing the heliopause. Scientists expected some differences, but the interstellar magnetic field showed a dramatic misalignment compared to our sun's magnetic influence. This wasn't a gradual transition, it was a sharp boundary suggesting something far more significant than anyone had anticipated. The readings point to Voyager 1 entering a magnetic turbulence zone where galactic magnetic fields twist and reconnect in ways that could, honestly, reshape our understanding of galactic structure. These aren't small ripples in space, they're fundamental forces operating on scales larger than our entire solar system. The magnetic field orientations Voyager measures might even channel cosmic material into denser regions, potentially influencing where new stars form in our region of the galaxy. Each measurement reveals that interstellar space has its own magnetic weather patterns, invisible highways of force that guide particles across vast cosmic distances. The spacecraft continues to detect these magnetic anomalies, proving that the space between stars is far more structured and dynamic than anyone predicted. The Cosmic Ray Avalanche. Crossing into interstellar space triggered an immediate and honestly shocking discovery. Voyager's cosmic ray detector recorded a sharp spike in high-energy particles accelerated to nearly light speed by distant supernovae and black holes. The increase wasn't gradual, it was abrupt, like stepping through an invisible barrier. This revelation exposed how effectively our sun's heliosphere shields Earth from the harsh radiation environment of interstellar space. We're living in a cosmic oasis, protected from particle bombardment that would be lethal to unshielded life. But the pattern isn't uniform. Voyager has detected systematic variations, suggesting natural radiation corridors, cosmic highways where particles preferentially flow. These measurements hint at larger galactic structures, possibly ancient scars left by stellar explosions that shaped our neighborhood millions of years ago. The spacecraft may be detecting pressure gradients that map onto invisible architecture spanning light years. Each cosmic ray measurement reveals more about the galactic environment, showing that we're not just measuring local conditions, but glimpsing the aftermath of cataclysmic events that continue to influence our cosmic neighborhood today. Whispers in the void. You know, the silence of space doesn't actually exist. Voyager's plasma wave instrument has completely shattered the old myth of cosmic emptiness by detecting these constant low-frequency oscillations that just permeate interstellar space. And these aren't just random fluctuations, no, they're structured signals, suggesting that the space between stars has its own unique acoustic signature. The instrument has even picked up multiple plasma density spikes, kind of like pressure waves moving through an invisible medium out there. Scientists think these could be shock fronts left behind by ancient supernovae that exploded thousands of years ago, still rippling through the interstellar medium today. So Voyager isn't just drifting through emptiness, it's flying through an invisible fog with its own distinct layers and properties. Some regions are hotter, others are denser, and together they create this complex three-dimensional structure that actually resembles weather patterns a lot more than the uniform void scientists once expected. This cosmic hum, it's really the background activity of our galaxy, a constant whisper from the space between stars. The plasma waves are revealing that interstellar space has its own dynamics, its own currents and temperatures, creating an environment that's far more active than anyone could have imagined. Interstellar weather patterns. Voyager 1 has actually passed through at least 2 distinct interstellar cloudlets since crossing the boundary, and this has revealed that the space between stars has structure, kind of like an ocean with currents and eddies. These aren't visible clouds though, they're regions where the plasma, dust, and gas density suddenly changes by factors of 2 or even 3 times. The spacecraft's instruments show evidence of these structured plasma ripples with clear boundaries, almost like atmospheric fronts out in space. NASA scientists now believe our sun is moving through the local interstellar cloud, and Voyager is helping to define its outer edges right now. This cloud exists inside the much larger local bubble, which is this enormous cavity created by ancient supernovae. These density shifts, they actually affect Earth's cosmic ray exposure over millennia. As our solar system drifts through different interstellar environments at 450,000 miles per hour, the radiation environment at Earth subtly changes, and that can potentially affect cloud formation and even mutation rates in living organisms. Voyager is showing us that interstellar space isn't just a straight path, it's really a gauntlet of invisible forces that create this complex, ever-changing cosmic landscape, complete with its own weather systems and boundaries. Digital resurrection. So, the 2023 communication crisis nearly ended humanity's only direct window into interstellar space. For months, Voyager 1 was transmitting incomprehensible data, its memory corrupted by cosmic ray bombardment. NASA engineers were suddenly facing one of their greatest challenges: remotely repairing a spacecraft that's actually older than most of their careers, and doing it with technology from the Carter administration no less. The solution took unprecedented ingenuity, rerouting decades-old code into backup memory areas while somehow maintaining all the critical functions across a 15 billion-mile gap. And every command took 22 hours to reach the spacecraft, so real-time troubleshooting was just impossible. The team basically performed remote surgery on a patient they couldn't see or touch. In April 2024, they finally had a breakthrough when basic telemetry resumed, and that was followed by the gradual revival of the scientific instruments. By June 2024, all 4 active science instruments were functioning again. This wasn't just an engineering triumph, it was humanity's lifeline to the only measurements we have from beyond our solar system's protective bubble. The rescue operation showed that even 1970s technology could be revived through innovative engineering, buying us precious additional years of interstellar data collection. Mapping the invisible galaxy. Voyager 1 is creating something, well, truly unprecedented, a navigational chart of interstellar space. With every data packet sent back, scientists are able to construct 3-dimensional models of the Milky Way's magnetic and radiation zones, using Voyager's measurements as crucial anchor points. This, honestly, represents the first real-scale cartography of our stellar neighborhood. It's a bit like having a weather satellite, but for the cosmos. The cosmic ray gradients, particle density readings, and magnetic field orientations are revealing natural shields and danger zones, and these could really determine whether humans can safely venture beyond our solar system. The radiation environment that Voyager measures is far more intense than what astronauts face in Earth orbit, which makes these maps absolutely crucial for any future interstellar missions. Some astrophysicists even believe the structures Voyager is mapping may influence star formation patterns across our galactic region. Quietly, the spacecraft is drawing the first blueprint of the space between stars, creating detailed models that get refined with every new measurement. This mapping project has, well, become the foundation for understanding how to navigate the void between stars, potentially guiding future spacecraft through the safest corridors of interstellar space. The protected oasis. Voyager's measurements have revealed a profound truth about Earth's place in the cosmos. Our solar system exists within a protective bubble that shields us from an environment far more hostile than anyone realized. The dramatic increase in cosmic radiation beyond the heliopause demonstrates how effectively the sun's magnetic field deflects dangerous particles that would otherwise bombard our planet. This discovery reframes Earth not just as our home, but as our shelter in a cosmic storm. The interstellar medium contains radiation levels that would pose serious threats to unprotected life, making our heliosphere a crucial barrier against galactic hazards. Voyager's data shows that this protection varies as our solar system moves through different interstellar environments over millions of years. The spacecraft's measurements of density variations and magnetic field changes suggest our cosmic neighborhood is far from uniform. We're traveling through a complex landscape of radiation zones, magnetic boundaries, and plasma clouds that create an ever-changing environment around our solar system. Understanding these variations helps explain long-term climate patterns and cosmic ray exposure cycles that may have influenced life's evolution on Earth. The Eternal Journey. Beyond its scientific mission, Voyager 1 carries humanity's most enduring message to the cosmos. The golden record attached to the spacecraft contains sounds, music, greetings in 55 languages, and 116 images representing Earth's diversity. This time capsule is engineered for extreme longevity, designed to survive over 1 billion years in the harsh environment of space. In approximately 40,000 years, Voyager 1 will make its closest approach to the star Gliese 445, passing within 1.6 light-years of this distant red dwarf. Long after Earth's continents have shifted beyond recognition, long after human civilization has evolved or disappeared, this record will endure. Voyager represents humanity's most lasting trace in the universe, an ambassador that will outlive our species. No other human object will leave the heliosphere for decades, making Voyager literally our longest-lasting monument. The spacecraft transforms from a scientific probe into something more profound, a message frozen in time, carrying the essence of who we were in 1977 across the galaxy for eons to come. This cosmic time capsule gives Voyager significance that transcends its scientific achievements, becoming humanity's first tentative step into eternity. Redefining reality. The space beyond our solar system isn't the featureless void astronomers once imagined. Voyager 1 has revealed a dynamic structured environment with weather patterns, magnetic topography, and radiation zones that shape our galaxy's invisible architecture. The transition from our solar bubble to interstellar space isn't clean. It's messy, complex, and honestly pretty fascinating. Magnetic fields don't align as expected, radiation environments change dramatically, and plasma waves suggest constant activity we never knew existed. Voyager's discoveries prove that interstellar space has layers, fronts, and boundaries, creating a textured cosmic landscape far more intricate than anyone predicted. The spacecraft continues operating on borrowed time, with NASA making difficult decisions about which instruments to shut down as power gradually fades. Early 2025 saw the cosmic ray detector powered down to extend the overall mission, but 3 science instruments continue transmitting their faint 23-watt signals across the cosmic void. Each day, Voyager 1 operates as a gift of knowledge from humanity's only direct sampling of the space between stars, rewriting textbooks with every transmission from the interstellar frontier. Voyager 1 reached the other side, and the reality is more extraordinary than fiction. The interstellar medium isn't empty. It's a structured, dynamic environment that challenges our understanding of cosmic architecture. From magnetic mysteries to plasma whispers, from radiation avalanches to cosmic weather patterns, Voyager continues revealing secrets that rewrite astronomy textbooks. This incredible journey proves that sometimes the most profound discoveries come from the simplest act of reaching beyond our boundaries. If you love real space exploration without the hype, smash that like button and subscribe to Stellar Tech for more mind-blowing cosmic discoveries. The universe is far stranger than we thought. What if the most terrifying message from the stars wasn't a broadcast, but an object? What if that object wasn't just visiting but reporting back to something else? In 2025, officials confirmed the detection of our solar system's third interstellar visitor, an object designated 3I Atlas. But as they decoded its transmissions and analyzed its impossible flight path, they confirmed a fear that humanity has held for centuries. This wasn't a random rock, it was a messenger. Let's explore this together. The impossible visitor. What if our third confirmed interstellar guest wasn't just wandering through space, but navigating it? When astronomical networks like Pan-STARRS first detected 3I Atlas in early 2025, it shattered every known classification. Unlike previous interstellar visitors, it was traveling at an unusually high interstellar velocity of 45 kilometers per second relative to our Sun, on a trajectory with a hyperbolic eccentricity of over 3.5. But it was its behavior that was truly impossible. It executed deliberate course corrections, moving with a precision that defied any natural explanation. This wasn't a random rock. Its massive coma, a gas and dust cloud stretching 700,000 kilometers across, pulsed with a steady, repeating electromagnetic signal, unlike the chaotic outgassing of a comet like Hale-Bopp. The trajectory it took was impossibly efficient, using the gravitational wells of planets it passed as if it had a complete map of our system, a feat that takes our own probes years of calculation to achieve. The sheer energy required for these maneuvers, conducted without any visible propellant, suggests a technology that operates outside our known physics. As 3I Atlas carved a path through our asteroid belt with surgical accuracy, it became clear this wasn't an exploration, it felt like an arrival. When physics stopped making sense. Here's where the story takes a sharp turn from a scientific curiosity into a genuine threat. Most objects from beyond our solar system follow chaotic trajectories, their paths dictated by gravity. But 3I Atlas demonstrated something entirely different. Its path allowed it to drift past several planets in ways that maximized gravitational efficiency, a maneuver that reminded JPL engineers of complex gravity assist routes they designed for probes like Voyager. When celestial mechanics experts like Jacques Lascar from the Paris Observatory ran the orbital simulations backward, they discovered something statistically impossible without intelligent intervention. The path of 3I Atlas required navigating through dense meteoroid streams and planetary collision zones with a mathematical elegance that was simply breathtaking. Its trajectory deviated from a purely gravitational path by a measured 0.05 arcseconds per hour, a tiny but constant thrust that had no visible source. It moved like a grandmaster's chess piece on a cosmic board, avoiding every conceivable threat with a precision that suggested either advanced, long-term planning or sophisticated real-time control. This wasn't a random space rock wandering through the cosmos, it was, as some scientists began to describe it, exhibiting piloted behavior. The object that defied reality. When NASA aimed the James Webb Space Telescope at 3I Atlas, the data it sent back challenged our understanding of reality itself. The thermal readings were the first red flag. Instead of chaotic heat bursts, 3I Atlas showed a consistent thermal signature of 250 Kelvin, pulsing with a precision of microseconds. JWST's principal investigator for the observation, Dr. Jane Rigby, noted that the thermal stability was unnatural. Webb's spectrography then revealed hyper-reflective compounds that appeared artificial, a material with a near-perfect albedo of 0.98, reflecting 98% of all light, something not found in nature. But the most disturbing discovery was a faint electromagnetic pulse repeating every 147.13 seconds. It matched the signature of a real pulsar, PSRB 1919+21, yet the object had no magnetic field capable of generating it. It seemed to be mimicking a signal, a form of cosmic camouflage. Webb's infrared analysis also found structural patterns resembling recursive geometric fractals, leading some to float the terrifying consciousness engine theory, comparing it to theoretical concepts like a Matryoshka brain, but on a smaller, mobile scale. The combination of these impossible features in one object moves it from unusual to unequivocally artificial. Two visitors, one terrifying pattern. The mystery deepened significantly when researchers cross-referenced 3I Atlas's electromagnetic signature with archived data from Oumuamua. The comparison revealed something that honestly sent shockwaves through the scientific community. The exact same 147-second frequency had been detected briefly in Oumuamua's data, a faint 3 sigma detection that was initially dismissed as noise. The crucial difference was that 3I Atlas's signal was a powerful, sustained 50 sigma detection, an unmistakable beacon. This discovery, championed by controversial Harvard astronomer Avi Loeb, completely reframed our understanding of both objects. Oumuamua had puzzled scientists, but now a disturbing pattern emerged. The evidence suggested that Oumuamua may have been a reconnaissance probe. If this theory held merit, then 3I Atlas represented something far more significant, not passive observation but active engagement. It was the difference between a single radar ping and a fully operational surveillance system. Some researchers now theorize that Oumuamua was the lock, and 3I Atlas is the key, designed not just to observe but to unlock something, whether buried on our planet or awaiting activation in orbit. When space objects make calculated decisions. The moment we knew for sure we were being actively monitored was the moment it changed course. Just as scientists believed they had mapped its future trajectory, the Very Large Telescope in Chile recorded a subtle but unmistakable 0.05-degree inclination shift, an adjustment of 180 arc-seconds. This wasn't the random drift of a comet. The object veered off its projected arc, aligning with a new vector that brought it closer to Earth's orbital plane. To mission analysts like planetary scientist Dr. Sarah Seeger, the implication was clear: this was a conscious decision. The maneuver occurred just 72 hours after the James Webb Space Telescope began its focused spectroscopic analysis, a time frame confirmed by NASA's Deep Space Network that rules out coincidence. This inclination shift is an incredibly energy-intensive move, and the action wasn't just responsive, it was almost defiant, a clear message that said, "We see you watching us." The mood at the DSN's Goldstone complex as they tracked this impossible change in real time shifted from academic curiosity to profound alarm. Ancient mathematics from the stars. As if its movements weren't enough, independent cryptographers at the SETI Institute, inspired by the lifelong work of pioneers like Dr. Jill Tarter, uncovered something extraordinary. Using Fourier analysis of the pulse's phase modulation, they found precise mathematical ratios hidden within the signal: the golden ratio, Fibonacci sequences, and the first 100 prime numbers encoded in binary. These weren't arbitrary concepts, they represent fundamental codes that appear throughout the natural universe. The precision of these patterns suggested a level of mathematical sophistication far beyond random cosmic noise. Even more disturbing was the dynamic nature of these signals. The mathematical patterns weren't constant, they changed subtly, reacting to solar activity and even our own radio emissions. Most chilling of all, researchers detected a brief disruption, a single skipped pulse that matched exactly with the moment James Webb first locked onto it. The object appeared to know it was being observed and had responded with a mathematical fingerprint that spoke a language older than human civilization itself. Organic chemistry from beyond the stars. It wasn't just a machine, it was carrying the very building blocks of life. James Webb's detailed spectroscopic analysis revealed its outer shell was coated in complex carbon molecules, and its NIRSpec instrument found evidence of adenine, one of the 4 nucleobases in DNA, via clear absorption lines between 260 and 280 nanometers. What was alarming was the purity and organization of these molecules. Unlike the chaotic racemic mixture of amino acids found in the Murchison meteorite, the compounds on 3I Atlas showed a 99.7% levorotatory excess, a homochiral signature that is a smoking gun for biological or artificial synthesis. Astrobiologist Dr. Heather Graham at NASA's Goddard Space Flight Center found the conclusion both thrilling and terrifying. The terrifying implication is that if this is a seed ship, its purpose might not be benevolent, it could be preparing the environment for a subsequent colonization effort. The presence of DNA components suggests a biology that might be eerily compatible or dangerously competitive with our own. When Earth responded to the cosmic visitor. The connection between 3I Atlas and Earth became far more unsettling when a classified high-altitude surveillance balloon managed by the U.S. Antarctic program detected something extraordinary. The balloon's instruments recorded a powerful microwave burst at 23.5 gigahertz, sharp and centered precisely above the South Pole. At first it was dismissed as interference, but its timing aligned perfectly with another angular shift in 3Y Atlas's trajectory. Just moments after the burst, seismic stations that are part of the global seismographic network recorded ultra-low frequency rumbles across the frozen continent. These deep, resonant frequencies were a perfect 0.0068 Hz, the exact inverse of the 147-second pulses being emitted by 3Y Atlas. The synchronization was impossible to dismiss as a coincidence. Somehow, this visitor appeared to be influencing activity on our own planet, possibly triggering responses from systems buried deep beneath the Antarctic ice. The object wasn't just passing by, it was actively interacting with Earth in ways that suggested a technological sophistication far beyond our current understanding. The asteroid belt death run. Right now, 3I Atlas is navigating a cosmic minefield, and it's doing so with terrifying ease. Its current path takes it directly through the main asteroid belt, traversing the dense Kirkwood gaps at over 60 kilometers per second. Unlike most comets, which have highly inclined orbits, 3Y Atlas is cutting directly through the belt's core. Planetary defense expert Dr. Amy Mainzer, former principal investigator of the NEOWISE survey, noted that its 700,000-kilometer coma is interacting with millions of untracked objects. More astonishingly, minor course corrections have been observed, suggesting it's actively avoiding even meter-sized debris with impossible precision. This avoidance system must be processing the trajectories of over 1.5 million known objects in real time, a feat of computation that dwarfs anything on Earth. Its journey isn't a dangerous run so much as a demonstration of effortless superiority over a hazardous environment, adjusting its path by mere hundreds of kilometers to avoid potential impacts. Rewiring our solar system's neural network. Scientists have now discovered that 3I Atlas's interaction extends far beyond simple gravitational effects. Its complex, dusty plasma envelope is actively interacting with the solar system's magnetic field, creating what researchers are calling an electromagnetic web effect. As 3I Atlas cuts through the inner solar system, it could be generating packets of charged dust that flow along the sun's natural electric currents toward Earth, potentially triggering geomagnetic storms. But the most disturbing discovery is the most recent. Observations from the Allen Telescope Array show that 3Y Atlas has begun emitting a secondary signal, a lower frequency, longer pulse at 700 MHz pointed directly toward the Orion constellation. As SETI astronomer Seth Shostak noted, a signal not pointed at us is infinitely more chilling. Some researchers believe it's calling for reinforcements. Others think it's reporting back on its findings. But either way, one conclusion seems undeniable. This was never just an interstellar rock. This was a node, a probe, a messenger, broadcasting to something else that is still on its way. The universe has sent us messengers, and we are only just beginning to learn their language. The mysteries of Oumuamua and other interstellar visitors remind us that we are part of a vast, interconnected cosmos filled with wonders we are yet to discover. The journey into the unknown continues. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the frontiers of science. Thank you for watching Stellar Tech.